November 15, 1942, at 1:00 a.m., Iron Bottom Sound, USS Washington's radar operators watched a large contact appear on their SG surface search radar scope. Range 8,400 yards, bearing 330 degrees. The target was a battleship. Everyone said night naval combat belonged to Japan. For 2 decades, the Imperial Japanese Navy had perfected tactics that made darkness their ally. They'd won every major night engagement since Pearl Harbor. They were wrong. USS Washington had SG surface search radar, Fire Co. Radar, operators who could see 8 miles through pitch darkness. Japanese battleship had nothing, no radar, no electronics. Her lookouts strained to see through darkness. Her optical rangefinders were useless without light. This asymmetry would kill them. Before November 15, 1942, Japanese owned the night. 4 American heavy cruisers sunk at Island in 32 minutes. Admirals killed, destroyers burning. After November 15, 1942, American battleship destroyed Japanese battleship in 7 minutes. 9 direct hits, 0 American casualties. Night combat advantage reversed overnight. Naval warfare changed forever. How did one American battleship dominate a superior Japanese force using technology most admirals didn't trust? The answer sat on Washington's bridge. Rear Admiral Augustus Lee, 54 years old, Olympic champion, the only flag officer in the U.S. Navy who understood radar better than the engineers who built it. Japanese expected visual combat, standard doctrine since 1920. They had no idea Washington was tracking them on radar for 20 minutes. What happened in the next 7 minutes would prove electronics could defeat experience. But first, Lee had to trust technology no other admiral believed in. November 1942, Pacific Theater bleeding both sides. Guadalcanal campaign entering 5th month. Marines exhausted. Japanese launching desperate counterattacks. Henderson Field remained the key. Control the airfield, control the island. Stakes were existential. If Guadalcanal failed, the entire American offensive strategy collapsed. Island hopping toward Japan would be questioned. Years added to the war. Thousands more casualties. Recent failures painted grim picture. August 1942. Island. Japanese cruisers surprised Allied force. Sank 4 heavy cruisers in 32 minutes. 1,077 Allied sailors dead. American ships had radar. Commanders didn't trust it. October 1942. Cape. Americans used radar to achieve surprise. Then formation fell apart in darkness. Ships fired at friendly contacts. USS hit by American shells, then Japanese shells. Sunk. November 13, 1942. First naval battle of Guadalcanal. Point-blank brawl under 3,000 yards. Ships fired at muzzle flashes. USS Atlanta took 19 shell hits. Rear Admiral Daniel killed. Rear Admiral Norman Scott killed. Only 2 American admirals killed in surface combat during entire Pacific War. Both died same night. Pattern was clear. Japanese owned darkness. Night naval combat in 1942 favored Imperial Japanese Navy for specific reasons. Japanese practiced night maneuvers until they could fight blind. Thousands of hours in low light conditions. Crews drilled on visual recognition at extreme range. Officers understood fundamental truth. Darkness neutralized American advantages in firepower and industrial strength. Japanese rangefinders were world's best. Optics, precision manufacturing, but they required light. Starlight, moonlight, searchlights. Without illumination, they were useless. Japanese doctrine relied on searchlights for targeting. Illuminate enemy, track, fire. This worked against opponents without radar. Aggressive doctrine built around rapid torpedo attacks. Type 93 long-lance torpedoes, range 20 miles, speed 49 knots. Oxygen propulsion left no wake. Japanese cruisers could launch torpedoes from beyond visual range. American ships wouldn't see them coming. American radar problem was different. Early 1942 radar was experimental. SC air search radar detected contacts at 40,000 yards, but information took too long to reach bridge. By the time Captain was informed, Japanese ships were already at visual range. Radar warning provided no advantage. More critical, commanders didn't trust radar data. At Island, USS Ralph Talbot detected Japanese ships, reported them as friendly. Formation commander ignored the warning. Japanese achieved complete surprise despite radar detecting them miles away. Technology existed. Doctrine didn't. Most American flag officers in November 1942 thought of radar as interesting experimental tool, not a weapon that could dominate combat. Admiral William had almost nothing left to stop Japanese bombardment force. Cruiser force shattered. He had one operational aircraft carrier, USS Enterprise. Carrier aircraft couldn't fight at night. His only option was strip Enterprise of battleship escorts, send them into Iron Bottom Sound for another night engagement. It was calculated risk. If battleship sunk, Enterprise vulnerable. But if Henderson Field destroyed, Guadalcanal lost anyway. Problem was night engagements favored Japanese. Most admirals were cautious about relying on radar completely. They'd been trained in an era when visual spotting and optical rangefinders were only way to fight. Radar challenged decades of doctrine and experience. Standard thinking said radar is unproven technology. We need visual confirmation before opening fire. This thinking had gotten 4 cruisers sunk at Island. Admiral Lee was different. Lee understood radar because he'd studied it, worked with engineers developing fire control systems, examined British reports on radar-directed gunnery, trained his crews to fight using radar as primary sensor. When other admirals said radar was unproven, Lee said radar would decide who controlled Pacific. Augustus Lee was 54 years old in November 1942, born in Kentucky in 1888. Graduated Naval Academy in 1908. His expertise wasn't traditional naval skills. Lee was marksman. At 1920 Antwerp Olympics in Belgium, he won 7 medals in shooting, 5 gold, 1 silver, 1 bronze. Best American Olympic shooting performance ever recorded. More importantly, those 7 medals came from understanding ballistics, trajectory calculation, wind compensation, mathematics of accuracy. Lee approached gunnery as physics problem. He understood fire control systems weren't about sailors' instinct or officers' experience. They were about mathematics, geometry, trigonometry. Calculate target position, calculate shell trajectory, calculate lead angle, execute with precision. Radar was extension of that principle. Instead of using human eyes limited to visual range, use electronics that could see through darkness. Instead of guessing at range and bearing, use radar that provided exact data. Instead of hoping for lucky hit, use fire control computers that calculated precise firing solutions. Lee had spent years preparing for this moment. He trained Washington's crew specifically for radar-directed night combat. Operators drilled until they could read radar scopes instantly. Gun crews practiced firing at targets they couldn't see. Officers learned to trust electronic data over visual observation. Now Japanese were coming to shell Henderson Field. Lee had 2 battleships, USS Washington and USS South Dakota, 4 destroyers, Task Force 64. Japanese had Battleship, 4 cruisers, 9 destroyers. On paper, Japanese had numerical advantage, but Lee had radar. The question was whether electronics could overcome Japanese night fighting mastery. Task Force 64 entered Iron Bottom Sound through channel, Washington leading. South Dakota 3,000 yards astern, 4 destroyers screening ahead. Lee knew Japanese were coming. Intelligence reports confirmed Vice Admiral was bringing bombardment force south. Battleship, heavy cruisers and light cruisers and Sendai. 9 destroyers. Japanese plan was shell Henderson Field, destroy American aircraft, land reinforcements unopposed. Retake Guadalcanal. Lee's plan was intercept them using radar. Standard American doctrine said wait for visual contact before opening fire. Too much risk of hitting friendly ships in darkness. Lee abandoned that doctrine completely. He positioned Washington to use radar as primary targeting system. SG surface search radar could detect ships at 35,000 yards. Fire control radar could track targets and provide firing solutions without visual confirmation. This had never been done in combat. British had used radar-directed gunfire against shore targets, but never ship to ship. Never at night, never in chaotic ship engagement. Lee was betting everything on technology most admirals didn't trust. Washington's SG radar scope glowed green in Combat Information Center. Operators watched sweeping line paint contacts on circular display. At 11:17 p.m., radar detected Japanese destroyers entering sound from northwest, range 28,000 yards. Lee tracked them silently. Japanese had no idea American battleships were there. In 90 minutes, that ignorance would cost them a battleship. USS Washington's radar suite represented cutting edge of 1942 naval technology. SG surface search radar mounted on mainmast, rotating antenna, operating frequency 3000 MHz, could detect large ships at 35,000 yards, smaller vessels at 20,000 yards. Resolution good enough to distinguish individual ships in formation. Critical advantage was Japanese had nothing comparable. Their warships carried no radar. They were blind beyond visual range. Mark III fire control radar mounted on each main battery director. Could lock onto target and track continuously. Provided range, bearing, and target motion data to Mark VIII fire control computer. This was revolutionary. Fire control computer could calculate firing solution using radar data alone. No visual observation needed. No optical rangefinders required. Mark VIII was analog mechanical computer. Weight 3,100 pounds. Contained gears, cams, and differential mechanisms that solved ballistic equations in real time. Input was target range, bearing, course, speed from radar. Output was gun elevation and train angles for main battery. System could predict target's future position. Calculate shell flight time. Adjust for wind, air density, barrel wear. Provide continuous firing solution as target maneuvered. Main battery consisted of 9 16-inch guns in 3 triple turrets. Each shell weighed 2,700 pounds. Muzzle velocity 2,300 feet per second. Maximum range 36,000 yards. Rate of fire was 2 rounds per minute per gun sustained. At 8,400 yards, Washington's guns could penetrate any armor on. Washington's crew had drilled extensively on radar-directed firing. Gun crews practiced firing at targets they couldn't see. Radar operators learned to distinguish target types from scope signatures. Fire control teams coordinated radar tracking with computer input. Lee insisted on one critical procedure: trust the radar. If radar showed target at specific bearing and range, guns fired at that bearing and range. No waiting for visual confirmation. No second-guessing the electronics. This violated every instinct developed through decades of visual combat, but Lee understood radar was more accurate than human eyes. Fire control computer calculated better solutions than experienced officers estimating by eye. Technology would prove superior to tradition. At 11:30 p.m., Japanese force maneuvered into Iron Bottom Sound. American destroyers engaged Japanese screening destroyers. Gunfire erupted, torpedoes in water, chaos in darkness. Muzzle flashes lit horizon like lightning. Tracers arced across water. Explosions reflected off low clouds. USS took torpedo hit. Magazine exploded. She sank in 8 minutes. 82 men lost. USS Preston engaged Japanese destroyers point blank. Multiple shell hits. Fire spread rapidly. She sank at 23:42 hours. 117 men lost. USS took torpedo hit in bow. 60 feet of forward hull destroyed. She from action. USS damaged by Japanese gunfire. Still operational but effectiveness reduced. American destroyer screen effectively destroyed. Washington's crew heard explosions echoing across water, saw ships burning. New destroyers were dying. Lee held position, tracked Japanese force on radar, waited. 000 hours. November 15, 1942. USS South Dakota, the other American battleship, moved forward to engage. Her radar had detected Japanese cruisers. South Dakota opened fire at 017 hours. Japanese searchlights immediately found her, illuminated her. Every Japanese ship shifted fire to her. South Dakota's hull lit up like stadium under searchlights. 14-inch shells from 8-inch shells from cruisers, 5-inch shells from destroyers. Metal screamed. Armor sparked. South Dakota had electrical problems. Circuit breakers failed. Radar offline. Gun directors offline. Fire control degraded. She could barely fight back. She took 27 shell hits in 3 minutes. Japanese concentrated everything on her. Destroyers closed for torpedo attacks. On Washington's bridge, Lee watched South Dakota getting battered. Saw her illuminated by searchlights 5,000 yards away. Heard her guns firing sporadically. Washington remained dark, silent, invisible. Japanese were fixated on South Dakota. Their searchlights swept water looking for more targets. They never found Washington. Lee tracked them on radar. 100 hours. Large contact appeared on Washington's SG radar scope. Range 8,400 yards, bearing 330 degrees. Radar operator recognized signature. Battleship. She was moving slowly through sound, heading to shell Henderson Field. Her crew thought they'd won engagement. American battleship was crippled, destroyers sunk or burning. They had no idea Washington's 9 16-inch guns were trained on them. In Washington's main battery plot room, fire control team input radar data into Mark 8 computer. Mechanical gears turned. Cams rotated. Computer calculated firing solution. Target, range 8,400 yards, bearing 330 degrees relative. Target course 110 degrees. Target speed 12 knots. Computer output gun train and elevation angles. Electrical signals transmitted to turrets. Turrets rotated. Guns elevated. Lee stood on bridge. Watched radar scope. Looked at darkness where was supposed to be. Saw nothing with his eyes. He gave order entirely on radar data. Commence firing. Washington was about to fire 9 16-inch guns at target nobody could see. 101 hours. Washington opened fire. First salvo. 9 16-inch guns fired simultaneously. Muzzle blast lit Washington like daylight. Shock wave rippled across water. Each gun recoiled 48 inches. 9 2,700-pound shells flew through darkness. Flight time 26 seconds. Nobody on Washington could see where they went. Radar tracked target. Fire control computer updated solution continuously. Second salvo fired before first salvo hit. 101 hours 26 seconds. First salvo arrived. Crew saw nothing coming. No warning. Darkness. Suddenly 9 16-inch armor-piercing shells hit their ship. Hit number 1. Main deck amidships. Penetrated. Exploded in engineering space. Killed everyone in aft engine room. Hit number 2. Forward superstructure. Demolished fire control position. Killed range finding team. Hit number 3. Waterline forward. Punch through hull plating. Seawater flooded compartments. Captain had no idea where shells came from. Darkness. No muzzle flashes visible. No warning. Second salvo arrived 30 seconds later. Hit number 4. Main turret number 3. Penetrated turret roof. Detonated ammunition inside. Turret destroyed. Entire gun crew killed instantly. Hit number 5. Bridge level. Destroyed navigation bridge. Killed several officers. Admiral was on nearby cruiser not. Captain survived but wounded. Hit number 6. Engineering space. Another hit to engine room. Slowing rapidly. Washington fired 7 salvos in 7 minutes. 75 rounds of 16-inch ammunition. 9 direct hits confirmed. Confirmed hits were 4 hits to engineering spaces, 2 hits to superstructure, 2 hits to main battery turrets, 1 hit at waterline. Damage to was catastrophic. Rudder jammed. She could only turn in circles. All power lost to aft section. Flooding uncontrolled in 3 compartments. Fire spreading through superstructure. Main battery disabled. Only 1 turret still operational. Speed reduced from 25 knots to 4 knots. Japanese sailors saw their own ship disintegrating around them. Explosions, fire, steel ripping. No idea where shells came from. Fired 4 salvos during engagement. All missed. Her fire control relied on visual spotting. She couldn't see Washington in darkness. Her shells landed 1,000 yards wide. 107 hours. Washington ceased fire, was done, dead in water, burning, sinking. Lee shifted target to Japanese cruiser, fired 5 salvos, turned away behind smoke screen. Japanese force at high speed. Admiral realized American battleship was in sound. Battleship with radar. Battleship that could see in darkness. Battleship that had just destroyed without being seen. Japanese northwest. Canceled bombardment mission. Henderson Field was saved. Washington's crew watched Japanese searchlights disappear, heard gunfire fade. Radar showed contacts retreating at 25+ knots. They'd won 7 minutes of firing, 9 direct hits on enemy battleship, 0 damage to Washington, 0 casualties on Washington, struggled for 2 more hours. Flooding couldn't be controlled. Fire spread to ammunition magazines. Captain ordered abandoned ship at 2:30 hours. Sank at 3:25 hours on November 15, 1942. Position 9 degrees 5 minutes south, 159 degrees 52 minutes east. Bottom depth 2,500 feet. Washington's victory had just changed naval warfare forever, but it would take months before anyone understood the magnitude. November 15, 1942. Dawn. Task Force 64 from Iron Bottom Sound. Japanese force fled northwest to Rabaul. Henderson Field undamaged. 0 bomb craters. 0 destroyed aircraft. Marines flew missions that morning against Japanese transports trying to reach Guadalcanal. Sank 7 transports. Killed thousands of Japanese troops before they reached shore. Japanese attempt to reinforce and retake Guadalcanal failed completely. Strategic situation reversed. Before November 15, Japanese could bombard Henderson Field with impunity at night. American forces couldn't stop them. Marines on Guadalcanal were isolated and outnumbered. After November 15, Japanese couldn't risk capital ships near Guadalcanal. American radar gave decisive advantage in night combat. Marines held the island. Tactical consequences were immediate. Japanese Navy never again attempted to use battleships to shell Henderson Field. They tried submarines. They tried destroyers. They tried air attacks. But they never sent battleships into Iron Bottom Sound again. Why? Because 1 American battleship had destroyed 1 Japanese battleship in 7 minutes using radar, without being seen, without taking damage. That demonstration changed Imperial Japanese Navy's entire operational calculus, but the long-term impact went far beyond 1 battle in the Solomon Islands. Washington's victory proved radar could dominate surface naval combat. Every navy in the world immediately accelerated radar development programs. United States Navy response was dramatic. January 1942, fewer than 100 American warships had any radar. January 1945, virtually every American warship had multiple radar systems. Fire control radar, air search radar, surface search radar, identification systems. Ships carried half a dozen different radar systems, each optimized for different functions. The electronic equipment became as important as the guns. British Royal Navy already had radar but accelerated integration into fire control systems. Type 271 surface search radar. Type 284 gunnery radar. Every major warship retrofitted. Soviet Navy began crash program to develop indigenous radar. They'd relied on British and American equipment. After Washington's victory, ordered domestic production prioritized. Even Japanese Navy, despite losing, attempted to catch up. They developed Type 21 air search radar and Type 22 surface search radar. But they were 2 years behind American technology. They never closed the gap. The transformation happened remarkably quickly. In January 1942, fewer than 100 American warships had any kind of radar. By January 1945, virtually every American warship had multiple radar systems. Ships were designed from the keel up with radar as primary sensor. Tactics and doctrine were rewritten around radar capabilities. The era of visual range combat ended. The era of electronic warfare began. Japanese investigated what happened. Admiral filed detailed after-action report. He described American battleship appearing from nowhere, destroying in minutes, disappearing back into darkness. Japanese naval intelligence analyzed the engagement. They concluded Americans had developed superior radar technology. They understood Washington had seen without being seen. They recognized this represented fundamental shift in naval warfare, but understanding the problem and solving it were different things. Japan lacked industrial capacity to mass-produce advanced radar systems. They lacked trained technicians to operate and maintain complex electronics. They lacked doctrine for integrating radar into tactics. Japanese response was modify existing tactics, avoid night engagements with American forces when possible, use submarines for supply runs instead of surface ships, rely more heavily on air power. These adaptations didn't solve fundamental problem. American radar advantage only grew larger as war progressed. Some historians argue that radar was the single most important technology of World War II naval warfare, more important than aircraft carriers or submarines or any weapon system. The lesson from USS Washington's victory isn't ultimately about technology. It's about leadership willing to trust new technology when conventional wisdom says otherwise. Admiral Lee had decades of experience in era when battleships fought with visual spotting and optical rangefinders. Every instinct developed through 34 years of naval service should have told him to be cautious with experimental electronics. His career had been built on mastering traditional gunnery. He was probably the best gun expert in the Navy. He could have relied on traditional methods because that's what he knew best. Instead, Lee abandoned those methods completely. He committed entirely to radar because he'd done the intellectual work to understand it. He'd studied the engineering principles. He'd examined combat reports. He'd trained his crews extensively. He tested the systems in exercises. He knew radar would work because he did it through study and practice. When the moment came in pitch darkness with destroyers sinking and another battleship crippled and superior Japanese force approaching, Lee trusted his radar operators and fire control teams to do something unprecedented. He ordered Washington to fire at target nobody could see using data from electronics that most officers didn't fully trust. The crews didn't let him down. The radar tracked perfectly. The fire control computer calculated accurately. The guns fired precisely. 9 salvos in 7 minutes destroyed Japanese battleship. 0 American casualties. The victory validated everything Lee had believed about radar. It proved that electronics could be more reliable than human senses. It demonstrated that properly integrated technology could overcome numerical inferiority and tactical disadvantage. Most importantly, it showed that innovation succeeds when leaders understand new capabilities deeply enough to trust them completely. That kind of leadership remains rare. Most commanders follow established procedures. They trust proven methods. They avoid risk by doing what has always been done. Innovation requires doing something that hasn't been proven in combat. It requires accepting risk that others won't accept. It requires trusting technology or tactics that haven't been validated by experience. Admiral Lee did all of these things. He organized his ship around unproven technology. He trained his crew to fight in ways no navy had fought before. He committed his entire force to battle plan that depended on radar working perfectly, and he succeeded. The result changed naval warfare forever. Night combat, which had been Japanese advantage for 2 years, became American advantage almost overnight. The technology that Admiral Lee trusted in November 1942 became the foundation for every navy in the world. The radar displays and fire control computers that seemed revolutionary in 1942 evolved into the modern combat systems that control warships today. The lessons Lee demonstrated, that electronics can provide better information than human senses, and that technology properly used can overcome superior numbers, remain relevant 80 years later. USS Washington's victory deserves to be remembered not just for what was accomplished that night, but for what it represented. A leader willing to trust new technology. A crew trained to use that technology effectively. A tactical victory that changed strategic reality. And a demonstration that innovation succeeds when knowledge replaces assumption, when study replaces tradition, and when courage to act differently produces results impossible under old methods. Admiral Augustus Lee never saw the end of the war. On August 25, 1945, 10 days after Japan surrendered, Lee suffered massive heart attack aboard motor launch in Bay, Maine. He was 57 years old. 3 years of constant stress commanding battleship forces in combat had taken their toll. Captain Davis, Washington's commanding officer during the engagement, survived the war. He retired as Rear Admiral in 1952. He died September 9, 1984 in Bethesda, Maryland at age 92. Lee was buried with full military honors at Arlington National Cemetery. His grave is marked with simple white marble headstone. The inscription lists his name, rank of Vice Admiral, and dates of birth and death. It mentions his 7 Olympic medals. It doesn't mention Guadalcanal. It doesn't mention that he proved radar could revolutionize warfare. Lee would probably have preferred it that way. He was never interested in glory or recognition. He was interested in solving problems and winning battles. 7 minutes. 9 hits, 1 battleship sunk, 0 American casualties. The night radar won the war.